before I start the lecture, anyone has any questions? Good. How many of you are done with your quiz 1? How many of you are still working on that? Okay, so quite a lot of you. So remember, the deadline for quiz is tonight, and just don't let it be like 11 p.m. to start the quiz in case something happens or you encounter technical difficulties. So make sure plan accordingly. Okay, any questions about anything in the course? So I have some of you emailing me that you want to see your solutions, your own work. So I post the solutions after each homework is, the deadline is passed, or like for the quiz as well. But so I assume that now you know the solutions. But if you specifically want to see what you got wrong, just email me. I sent you the answers, your specific answers after the deadline. Does that make sense? Okay. So I thought it's really helpful to go through the assignment. So here you see that at the top you have like homework assignment, but they are in the format of the quiz. That's why Candace says quiz summary. So how many of you are thinking, this is kind of like not a good usage of our time in the class to go through the solutions? Okay, few of you. How many of you think it's good that we go through them? Okay, since most of the students, would like to go through them in the class, so I'll go, and I apologize to the students that they already know the solutions or they'll be bored with that. Okay, so, as you see, the average score is like 74. So as we progress with the course, the average score becomes like lower and lower. That's why I encourage you to go to your SI Pass leaders, and these are like all the hours that are available. And if you cannot go to them, come to my office hours, and just like regardless you're going to SI Pass or not, feel free to stop by my office hours. And if my office hours don't work for you, just email me. I schedule in person or like Zoom meeting, and I have students come to me and I tutor them. Basically I have like tutoring sessions myself and go through the materials. So don't let anything that you don't know remains unknown to you. Does that make sense? Okay, and the average time was like 20 minutes. So, and I have students that they're telling me, and one of your SI Pass leaders also was telling me that last semester students were talking in the class that they get really distracted. And as a student, when I was sitting in the classroom, I didn't want to reach out to the person that is sitting next to me or in front of me to say, be quiet. Sometimes I would do that, but to my friends, But to the person that I don't know, maybe I don't feel comfortable to talk with them and confront them. So I am your instructor, and this is my responsibility to make sure everyone is learning in the class. Kind of like the mask policy that we talked about. That's, maybe you don't want to tell the person next to you that wear your mask. What if they say, I don't want to? You don't want that. But as an instructor, I have the power to tell you this is university policy, you should wear your mask, or you should be quiet in the class. I realize some of you reading books in the class or like watch movies. I know that, I'm aware of that. And as long as you don't distract other people, that's fine. I can just I'm trying my best to show you that I care about you and do my best to teach well and make sure you are learning. But if you insist that you don't want to listen to me, or you want to prove a point that coming to the class is not useful, I cannot change that. There's so much I can do. But I ask you to don't distract other students. So if you want to do, work on your, other homework assignments or read a book or like watch a movie, just sit somewhere that other students cannot see your screen so they don't get distracted. Because, we're not like in elementary school or middle school, high school anymore. I cannot just walk around and then see who is doing what. As long as you don't distract other people, that's fine. Plus, I'm recording the lecture, so I prefer to be here. I can just carry my iPad with me, but you cannot see the board. So just be mindful of the things that I just mentioned. So now that being said, the first question, what is not a scientific notation? What is the first thing we do when we write a number in scientific notation? Yes, the number should be between 1 to 10. Is this between 1 to 10? What about this one? What about this one? So this is not a scientific notation, and this is also between 1 to 10. So that's the whole point of this question. And if I tell you, write the scientific notation for the number 15,000, what is the first step? Yes, so 1.5, this number is between 1 to 5. If I write like 150 is not between 1 to 5. If I write, 15 is not. And I write multiply by 10 to the power of something. So right now, if I tell you what is the scientific notation for this number, and I tell you 1.5 multiplied by 5 to the power of something, you know that is not the case. It should be 10 to the power of something. And I tell you guys to, kind of remember this better, or like an easier way to remember this. If the number is large, the power is positive. 15,000, is this a large number? It is, right? So the power would be positive. And 15,000, if you don't write any decimal, an implied decimal point is here, right? And you wrote the number between 1 to 10, so you change the decimal place to here. And you count the difference, 1 digit, 2 digit, 3 digit, 4 digits. So you write 4 here. So this is the scientific notation for the number 15,000. Any questions? Good? Okay. So these types of questions, we talked about them before too. If I have a ruler that has markings every 1 millimeter, what is the number that I can read with that? If I call this A, B, C, D. Which one? A, right? Is this clear why A? Why can't I just read like 16 here? Why this answer is not correct?
Because it's not that precise.
Exactly, because you should read the number corresponding to the precision that you have. If you have a ruler that has markings every millimeter, and this is kind of accurate. I guess, millimeter is a little smaller, but I want to demonstrate it somehow that you guys can see. So if, I want to measure something that is like this much, right? And I want to report it, one, you count, this is 0, 1, 2, 3, 4, right? Till here, and then you say that, okay, this is 4.4. And the last digit always is estimated, remember, right? So if I read the number here, like 4, and are you following what I'm doing? 1, 2, 3, 4. So this was the length I wanted to measure. Here was like 4.4, right? If I tell you the number is just 4 without any decimal point, it means that the number 4, the last digit, which is like 4 itself, is uncertain. The number can be between 3 to 5. I know that my number is not 3. I know my number is not 5. So 4 is certain. I certainly know that the number is 4 point something. But the second digit that I read, 4.4, that 4, I estimated that. It's not that accurate. Does that make sense? So if I have a ruler that has markings every 0.1 millimeter, and I asked you this in your exam, I'm just telling you, and I asked you what measurement can be performed or cannot be performed with this ruler. If this was like 0.1 millimeter, and I was like giving you the same answers. Which one was the answer? Or could be the answers? Which one of these options?
C.
So C can be the answer. How many say A? Is a question, So I changed the question. We have just changed 1 to 0.1. I tell you, we have a ruler that has markings every 0.1 millimeter. What measurement can be performed with this ruler? And I say choose as many options as possible, right? So one of your friends said C would be the answer for this question. How many of you say it's A? Okay, B, C, okay, D, C and D. Okay, so if you have like markings every 0.1 millimeter, you always add 1 digit to it. And then the marking that you have until like, 0.1, every 0.1 would be certain, the next digit would be estimated. So in these cases, so C and D both can be the answers. Is that clear why? So here, when we had like 1 millimeter, the reading that we have should have like 1 point after decimal place, right? So if you have like 0.1, your reading should have like 2 decimal points, or like 2 digits after decimal point. Does that make sense what I'm saying? Any questions? Yes?
Okay, so basically what you're saying is that the reason it's not 16 and 16.0 is because it's more accurate than 16. And even though it might seem like the line is a little bit farther over, it can't be 16.1 because it's not precise.
So the last digit, so 16.1, it can be 16.1. So with this ruler that have like markings every...
But like for the specific example.
So for this example, the original one you're talking about?
Yes.
Okay, for the original one that we have markings every 1 millimeter, the number that I read, now I'm talking about 16, so I use that as an example. It can be 16.0, 16.1, 16.2, 16.3, 16.4, and 16.9. So all of these things are like estimated, the last digit. The reason 16 is not correct because the last digit is estimated. So it means that my reading can be 15 or 17. Remember, we would add up and down. But I know as a fact my number is not 17. I know for sure it is 16. So that is certain. So I put like a decimal point and write another number afterwards because that is the one. So in this reading here, I try to zoom it. So here is another example, I didn't write till 16, I wrote till 4, right? But when I want to read this, okay, I guess now it's like really zoomed. So let me use this one. So if I tell you here is like, I don't know, whatever length I have is kind of like a small piece of, I don't know, paper, or like really a small thing that I want to measure, right? So here, if I tell you what is this length, what do you tell me based on this ruler that I draw here? This is 0, 1, 2, 3, 4, 5, right? What is this length? What is it?
4.5.
Yes, so you tell me for sure. If someone tells me it's 4.4, or someone argues that I read that 4.3, it can be, right? It depends on how we read this. But 4 for sure, right? If I write this just 4, is this the answer? You tell me it's not 4, right? You say that I think it's like between 4 and 5, but it's kind of in the middle, and then you tell me this is like 4.5. And I say, okay. And you say the last digit is estimated. So that's why we cannot say only 4, right? Because it's not 4. Does that make sense what I'm saying? Any questions? Clearer? Okay. Just feel free to also email me or like ask your SI Pass leaders or Yeah. But I tried this to be clear. I hope it's like clearer, at least right now. Which sentence is not correct? In a reported measurement, digits that are making the decimal place are called significant digits. Is this correct or false? False. Why?
Leading zeros aren't significant. They only serve to show you where the decimal point is.
Exactly. And in the definitions we say, digits that are not making the decimal place, are called significant digits. The ones that they make the decimal place, they just want to locate the decimal point. They're not significant digits. And just like the definition of significant digits. So I encourage you to go back to the slide, if that's a slide in that session that we talked about significant digits, if you have like questions. But the rest, significant figures represent the precision of a measured quantity. In a reported measurement, the non-place holding digits are called significant figures. The greater number of significant digits, the greater the precision. All of the other sentences are correct. Any questions? Questions? Good? Okay. So, how many significant figures this number has? So, is this digit significant?
No.
Is this one significant?
No.
What about 2?
Yes.
All non-zero digits are significant. What about these zeros?
Yes.
Those are also trailing zeros after a number after decimal point. These are like significant. So, 3. Is the following statement true or false? Leading zeros are significant. Leading zeros are not significant. Okay? Oh, right. Next slide. Next slide. Okay. Trailing zeros are always significant. Is this correct or false? Can anyone tell me what types of trailing zeros we have?
Ones before and implied decimal point.
Uh-huh. So are those significant? Right? So we have like different types of, trailing zeros. So let me ask you this. How many significant digits this number has? Two. What else? Remember that we said these 6, okay? Do you remember when we talked about like 350? And we said these types of trailing zeros, they are like confusing, and we don't know how many significant digits the number 350 has, and we should use scientific notation to prevent that confusion, remember? So not all trailing zeros are significant. So this is an exception, right? So again, I encourage you, you remember that slide that I had about like significant digits and I was like repeating that every session? So that is really important. Go back to it and kind of like go through this so these concepts become more clear, okay? Good? Questions?
Is there a way to tell that, like, from looking at it, that some zeros aren't significant?
We cannot tell based on this. These trailing zeros are like ambiguous and we should prevent them by writing scientific notation. So if I write 3.5 multiplied by 10 to the power of, can anyone tell me what is that power? 4, 5, right? So here the implied decimal place is here, right? When I don't write it, and I change the decimal place here, and I count 1, 2, 3, 4, 5, and the number is big, so the power is positive, right? So if I write the number like this, we know that, okay, this number has 2 significant digits, right? But if I write it 3.50 multiplied by 10 to the power of 4, right? Now you know, okay, this number has like 3 significant digits. Or if I write it 3.500 multiply by 10 to the power of 3. Or like, is it 3? Right? Did I write it right? So 3 point, if I put like 2 zeros, it would be, did I write the other one correct? 3.50 multiplied by 3, right? 3, 1, 2, 3, and then 2. Did I write this correct? Can anyone help me? So if I have like, so 3.5 multiplied by 10 to the power of 5 is this number for sure, right? 1, 2, 3, 4, 5, right? And if I want to write this as like 3.50, so 3.50, I can write that as like, okay, so this is the thing that I confused myself. Okay, now it should be, so these numbers, 3.5, 3.50, 3.500, all of these numbers are the same mathematically, right? So the powers would be the same. That's why I confused myself. So all of these numbers mathematically are the same. They just show different precisions. It's kind of like the examples that I gave about like 16. If I write 16.0, it means I had a ruler that had markings every 1 millimeter. If I write 16.00, I had a ruler that had marking every 0.1 millimeter. Does that make sense what I'm saying? Anyway, so if I write the number like this, I know I have 2 significant digits. I have 3. Here I have 4. Here I have 5 and 6. So this is how we distinguish how many significant digits this number has. As itself, we cannot say. Okay? Good? Okay, if I tell you I brought 1 book to the classroom, how many significant digits the number 1 has? Why? It's not a measurement. It's an exact number, right? So exact numbers have unlimited significant digits. And anything that we talk about in the class, you're going to see really similar things in your exam. So, it would be really unfortunate if I asked you this, and then instead of 1 book, I said you had like 100 students in the class. How many significant digits the number 100 has? And then I write ambiguous because we just talked about this, right? 100 or unlimited 1, 2, 3. And if you get it wrong, it would be unfortunate because we just talked about it, right? I meant to go to the. Okay. So, which of the following sentences is correct? Which one? If I call this A, B, C, D. A. So why B is incorrect? So I want to round this to 1 significant digit. What would be the answer?
0.05? 0.06.
So 0.05 or 6. So you see, when you want to round to 1 significant digit, remember, if I always tell you, remember this example. 0.0007, it has 1 significant digit, right? 0.00009, it has 1 significant digit. So when you want to round it to 1 significant digit, the answer won't be 0. It would be 0.0. And here, you look at the number after 5, right? If it's more than 5 or 5, you drop the last number and add 1 to it. So we call it round up. And round down, it means that we just write the number as it is. So if I had like 549, and I wanted to write the number with 1, round it to 1 significant digit, what would be the answer? 0.05, right? You look at the number after 5 is less than 5, so you just drop it and you don't worry about it. Clear? Questions? Okay. Considering section 2.4, significant figures and calculations, is the following statement true or false? So how many significant, first of all, you have multiplication. What do we focus on, decimal point or significant digits? Significant digits. How many significant digits this number has? How many significant digits this number has? What about this one? So how many significant digits the answer should have? How many does it have? So this sentence is false. What would be the correct answer? Right? It has one significant digit. So remember, for your exam, as I said, this example, remember that this number and this digit can be anything, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has one significant digit, and remember 350, we don't know how many significant digits it has. It is ambiguous, and we should use scientific notation to prevent that. So I'm going to ask you in the exam how many significant digits this number has, and again, some students get confused, so try not to be one of the students who get confused. Okay, so now, how many, first of all, what do we focus on here, significant digits or decimal points? Significant digits, right? Because it's multiplication. How many significant digits this number has? And I zoom it so you can count better. 7, right? The zeros that are between numbers, between digits, are always significant, right? And non-zero digits are always significant. What about this one? What about this one? So how many significant digits your answer should have? 3, right? So that's why this is the answer. What is the answer to the following mathematical operation? So I don't even have to put the number in calculator if I know how to do this, deal with decimal point significant digits. So here I have like subtraction, addition. What do I focus on? Decimal places. And I say here I have 3 digits after decimal points. We don't work with significant digits anymore. What about here? 3. What about here? What about here? 1, 2, 3, 4, 5, 6, 7. What about here? And we always consider the one that is lowest. What is the lowest between these? So my answer should have 1 digit after decimal point. Which one of these represent that? D, right? So I don't even have to put the number in calculator. Sometimes in your exam you have to put it because maybe one answer would be 2.0, right? But here you didn't have to. What does the following definition represent? Using units as a guide to solve problems. Anyone just shout it? Okay, louder. We were just like, sometimes in concerts, the singers say, no, it's not loud enough. Okay, I want everyone to say it. Everyone. So using units as a guide to solve problems. What do we call that? Okay, good. I want everyone to kind of like, wake up if you're sleeping. Again, I apologize if these are like repetitive or like boring to some of you, but as you see, some of the questions, there are so many students, they don't know the answer, so I just kind of want everyone to be on the same page. In calculation, sometimes we are allowed to skip units. False. We are never allowed to skip units. In any question that I give you, I expect you to write the units, and you can use the units as a guide to solve a problem, and we call that dimensional analysis. Okay, so now here's the fun stuff. So I tell you to convert 29.99 inches to centimeters, considering 1 inch equals 2.54 centimeter. And I'm going to tell you, if you don't know how to work with the units, you will suffer throughout this course, because we're just solving problems. We have like some definitions too, but half of the course would be solving problems. And in all of them, we use dimensional analysis and we use conversion factors. So, listen well. Anything that you want to find that you don't have, write a question mark and write it. Now, in the question, it tells me that convert this much of inches to centimeters. So I want to find centimeter. So I write question mark centimeter equals 29.99 inches. This is the first step, to know what you want to find, what you are given. Are we good so far? And then you write a conversion factor that in its denominator, it has the units that you want to eliminate. In the numerator is the thing that you want to find, centimeter. Good so far? Can anyone tell me what is the number that I should write in numerator? What about denominator? I just write the information that is given to me here. And if you do the math, you get this number from your calculator, right? So we're dealing with multiplication, right? So should I focus on decimal places or significant digits? So how many significant digits this number has? How many significant digits this number has? Unlimited. Remember, because defined quantities, I cannot write here. This is unlimited. Defined quantities have unlimited significant digits. So your answer should have 4 significant digits. So you round it to 4. So 1, 2, 3, 4, and the number after 7 is less than 5, so we just drop everything. We don't worry about it. Any questions? So I think this is one of the most, one of the trickiest questions from your homework 3. And as you can see, there are more than half of the students, they answered it incorrectly. So I'm going to for sure ask that in your exam. And since I explained that to you, I expect you all to know that, okay? And it's the same thing. If I want to convert gallon to liter, right? Again, that's a defined quantity. You don't count the significant digits of those. It's basically unlimited. And comparing unlimited and that number, whatever your measured quantity is, that measured quantity would have less significant digits compared to unlimited. Which conversion factor is not correct? If I say A, B, C, D. C, right? Because 1 inch is 2.54 centimeter, and I can write it 2.54 centimeter 1 inch, right? So if I write 1 centimeter over 2.54 inch, that doesn't make sense, right? And remember, all your conversion factors, mathematically they should be 1, because these numbers, these two quantities are 1 inch equals 2.54. So this is mathematically 1, but this is mathematically not 1. Any questions? What does the following definition represent? The ratio of mass to volume of a substance. Yeah. I expect all of you to say it. All of you say density? So density is mass over volume. And I know you think that this is really simple, but in the exam I have students that they may make a mistake. In this case nobody got it wrong, but be sure that You remember that for your final exam or like for your exams as well. Which of the following statements is not correct? You cannot diagram conversions using a solution map. You can, right? So that's why the sentence is not correct. And the other sentences are correct. A solution map is a visual outline that shows the strategic route required to solve a problem. For unit conversion, the solution map forces on units and how to convert them from one unit to another. A solution map is a visual outline of the solution to a problem. Any questions? How many significant digits this number has? 1, right? And this number, what does this number represent? If I want A, B, C, D. So you write your number 25, and remember, here is your decimal point, and then you want to move, it's 10 to the power of 2. It's basically, 0.01. So you move 1, 1, 2, right? With the same manner that you write scientific notation and you count how many digits you shifted the decimal place, is the same thing, So here it would be like if I give you this and you want to write scientific notation, you write it between 1 and 10, and then say 10 to the power of negative because it's a small number, and then you say that, okay, I shifted the decimal point 1, 2. So this is kind of like reverse of what we learned, and then you implement the kind of like reverse of what we just said. Any questions? Okay. Matter and energy. Can anyone tell me what is the definition of matter? What about you guys that are sitting there? The one in the middle? Can you tell me what is a matter? What is the definition of matter? Any guess? I mean, we don't have, I don't want you guys to feel like you should say the right answer. I mean, for your exams, you should if you want to, get a good grade. But right now, I don't mind even if you tell the wrong answer.
It makes everything.
Yes, it makes everything. So what else? Exactly. So anything that occupies a space and has mass, okay, is an, element. So it's one type of matter, yes. So, but what is the specific about it? So this, I guess this screen here is also matter, but is it an element? So what is it that makes something an element? What is it?
It can't be broken down into another substance.
Exactly. So what about the guy next to him? Do you have a mask? Yeah, can you wear it? Okay. So can you tell me so they are like, is a substance that cannot be broken down into simpler substances, okay? So because it was, really funny, now tell me what is compound? What is it? Exactly. So if we put elements together, and usually, when we put elements together, they form some sort of bonds too. Exactly. So compounds, and I wrote it here. I know it's cluttered, but I want it to be like under compound so you don't confuse them. A compound is a substance that's composed of 2 or more elements in fixed, definite proportions, and meaning that if I have water and I'm going to teach you water is H2O, you will never find water as H3O or like HO. Always 2 hydrogens, 1 oxygen. So they are composed of elements, and they have the same, they have fixed, proportions. And now, can anyone tell me what is the mixture? Yes?
Isn't it a substance that can be separated again?
Exactly, yes. So that's one way to put it. So a mixture is composed of different substances. Yeah, basically, in a mixture, you can see different substances. And they are not chemically united, but they are just like simply mixed together. So if I have like some tea and I put sugar on it, they don't form, the sugar and tea, they chemically don't bond. I just simply mix them together. Okay? So anyone can tell me what is heterogeneous mixture? And you can just kind of like look at the photo here too. You see, what is it about this photo or like this mixture?
They don't mix.
Exactly, they don't mix. And you can see the substituents, right? And the composition of this mixture is not the same throughout. In the, above here, you see like oil, here you see water. So in a heterogeneous mixture such as oil and water, the compositions varies from one region to the other. If I, measure composition here and here, the compositions would be different. And then reverse would be homogeneous mixture. In a homogeneous mixture such as salted water or like sweetened tea, the composition is the same throughout. So if I have like sweetened tea and unsweetened tea, and I tell you, just tell me which one is which. And if I just like put a little sugar, like 1 teaspoon, on one of them, probably you cannot distinguish because they are like the same, So the composition is the same throughout. Any question about this? So here again, because I know that this may seem like obvious, and okay, I know what is element, what is like an atom, but if you don't know these things well, you cannot learn this course. So that's why I'm really emphasizing on these, definitions. So again, elements, they have like specific chemical and physical properties. They cannot be broken down, as your friends say, they cannot be broken down into different elements or different substances. And here we have like the periodic table of elements. I also have the picture for people at home that are watching the video. And you have like these periodic table here. And you have like the elements listed in the periodic table. And we talk about this more in the next chapter, but I just want you to know where you can find the elements. So all the things that we encounter with all masses are like substances, they are made of elements. And here we have another definition, atom. Remember that we said matter is ultimately composed of atoms, and there are like submicroscopic particles that they are like building block of matter, right? And all your elements are also composed of atoms, and they are really small. And atom is the smallest identifiable unit of an element. Good? Okay, and then molecule. And again, as your friend mentioned, we can have like 2 or more atoms joined in a specific arrangement by chemical bonds, and we call them molecules. And it's really similar to compounds, And atoms are bonded together to form molecules, and then they can have like different arrangements. And this is basically what we're dealing with in this class, having like different compounds, different molecules, and so on. And we had like, if we can classify matter based on state or based on composition. The previous slides, when I talked about like pure substances, mixtures, those classification was based on composition. But we can also classify them based on state. And this was kind of like the summary of what we went through, right? We had like solids, liquids, gases, and they had like different properties. And tonight, when I write your quiz and post it like tomorrow morning or tomorrow afternoon, I'm going to ask you about this table. So make sure you know what was gas, what was liquid, what was solid. And also here I have the summary that matter can be pure substance or mixture. So pure substance can be element or compound. Mixture can be homogeneous, heterogeneous. And mixtures may be composed of 2 or more elements, 2 or more compounds, or combination of both. And I give you this in your homework tonight, and I say, is the following statement true or false? Or I say, maybe I can say, heterogeneous mixture may be composed of 2 or more elements, 2 or more compound. And again, because heterogeneous or homogeneous mixture are part of like mixtures, the sentence will still be correct. But I'm going to ask you that. So before I rush through everything else, or like we'll be having time deficiency, let's first do the assignment, the attendance, and then see how many minutes, if any, we'll be having. And the questions that I asked you in attendance, I'm not going to grade. So don't worry about that. Just answer it. I just want to see how many people learned what I taught them, or what should I emphasize next session. So make sure to answer the question. But as I said, I'm not going to grade it. It's kind of like the questions that I asked you in the class. I just want, to participate in the class and, kind of like don't fall asleep. But I'm not going to grade them, or like it doesn't affect your grade. Okay. Anyone has a problem with the link? You have a problem? Okay. You have a problem with the link? Anyone else has problem with the link?